Okay, for the final couple of examples here, now we want to write an equation of a line. I know it doesn't say it, but I'm going to say it specifically in slope-intercept form. That passes through, in this case, the point negative 2, 2, and it's perpendicular to this line. So here's what you're going to have to remember. If it's perpendicular to this line, 1, the slope of this line is 2/3. So the slope of a line perpendicular to that should be the opposite reciprocal of 2/3. So the opposite reciprocal of 2/3 is negative 3/2. Opposite reciprocal of a positive is a negative, and then you flip the fraction. And it passes through this point, negative 2, 2. So just like the previous couple of examples, even though we were writing equations of parallel lines, we first wrote the equations in point slope form. Because we have a point right here, I'm going to label x sub 1, y sub 1, and then we found the slope. This is the slope of a line perpendicular to it, negative 3/2. So now this is m, or this is a symbol for perpendicular, the perpendicular slope. Upside down t means perpendicular. So we have a point and the slope, the equation in point slope form. I'm not going to rewrite point slope form again. I've already written it a couple of times. Y minus y sub 1, so minus 2, equals m negative 3/2 times x minus x sub 1. So minus negative 2 turns into plus 2. Now to change that to slope-intercept form, we want to solve it for y, which means distribute the slope. Y minus 2 equals negative 3/2 times x is negative 3/2 x. Negative 3/2 times positive 2. I'm going to do the work over here. You make 2, 2 over 1. You can just cross-cancel these 2's. Then it's negative 3 over 1 or negative 3. You would get the same thing if you just multiply negative 3 by 2. That's negative 6. 2 by 1, that's 2. Negative 6 over 2 is negative 3. Okay, then solve the equation for y to put it into slope-intercept form. So add 2 to each side. Only add 2 to the negative 3. So y equals negative 3/2 x, and then negative 3 plus 2 is negative 1. That's your equation. If you actually graph these two lines, this one and this one, you would see that these two lines are perpendicular. One, they have opposite reciprocal slopes, and if you graph them on a piece of graph paper like I have here, you would see that they intersected at a right angle. This line right here actually should pass through this point. So you can double check it, even though I'm not going to take the time to do that right now, by graphing. And we'll go over one other example. So on this last example, even though I didn't write out the directions, I want to write an equation of a line specifically in slope-intercept form that goes through the point 3, 1, and it's perpendicular to this line. So be careful. We do have a point, but before we figure out the slope, we need to put this in the slope-intercept form. We need to solve this equation for y. So in order to do that, divide both sides by 2. Y is equal to 4 divided by 2 is 2. 2x, and then minus 3/2. I'm just going to leave it like that. You can write it as minus 1.5, but here's what we're concerned about, the slope. The slope of this line is 2 or 2 over 1. So we want the opposite reciprocal of that. Slope of a line perpendicular to this is negative 1/2. Remember the symbol right here, upside down t. Slope of a perpendicular line is negative 1/2. So this is the slope, or m. This is your point, x sub 1, y sub 1. So even though I want to write the equation in slope-intercept form, we have a point, we have the slope. I'm going to use point slope form first. Y minus y sub 1 equals m negative 1/2 times x minus x sub 1. So then we need to solve this for y. Distribute the slope. Y minus 1 equals negative 1/2 times x is negative 1/2 x. Negative 1/2 times negative 3 is going to be positive, and then 3 over 1, 3/2, or 1.5. And then add 1 to each side. Y is equal to negative 1/2 x plus 2.5. So that's the equation specifically in slope-intercept form.